Howdy, howdy, this is Mr. Potter. In our previous lessons, we've been dealing primarily with one-dimensional data structures, arrays and array lists. And we will find it helpful to start dealing with multiple dimensional array structures. Basically, I can envision the idea of putting an array in an array. And I can do this explicitly. Let me go ahead and start this off. Public class matrix begin, and public static void main string args. And what I can do is I can say int array array gets new int 10. And what this did to us in the past is this created 10 spaces in my array that I could store integers in. So what I really want to do is I really want to have an int array. In other words, an array of arrays. And I'm going to go ahead and call this matrix. And I'm going to say new int, and I'm going to have 6 rows and 5 columns in it. Just completely arbitrary numbers that I picked, but what's important to note is that I'm creating an array of arrays, so I have 5 of these int arrays. So each of these int arrays has size 6, and I'm creating 5 of them. So I can think of it as 5 successive rows of 6 elements, or I could think of it as 6 rows of 5 elements. It's actually going to be helpful to think about it in that latter case. So what I can do is I can fill this up using our traditional loop. So I'll say int actually for int row gets 0, row is less than matrix dot length row plus plus. And then in here I can say for int call gets 0, call is less than matrix sub row dot length. In other words, I'm essentially asking each row how long it is, and that's how many columns I'm going to have. And this allows us to have something that's called jagged edges. So in other words, I could envision a situation where I would have a matrix where the first row had 6 elements, the second row had 15 elements, and the third row had only 3 elements. But for our purposes today, we're going to be talking about rectangular matrices, where each row has the same number of columns in it. That being said, it's usually a good idea to go ahead and let this index be determined by the loop control variable for the outer loop. And what I'm going to do is in spot row comma call, I'm going to assign a value. Let's go ahead and say row plus call plus 2. So what's happening here is I can imagine in my matrix, which looks something like this. Each row has 6 elements in it. Excuse me. There are 6 rows with 5 elements in each. So in this first position, this is row 0 and column 0, so it's going to be nothing plus 2. This next position is going to be row 0, column 1, so this is going to be nothing plus 1 plus 2, which is 3. And it's going to be 4, 5, and 6. And we continue, so this next one's going to be row 1, column 0, so this is going to be 3, 4, 5, 6, 7. This is going to be 4, 5, 6, 7, and 8. 5, 6, 7, 8, and 9. And so forth. 6, 7, 8, 9, 10. And then this would be 7, 8, 9, 10, 11. So let me go ahead and make this a block comment. So I know that's what it should look like. And So this is how I've assigned it. I've assigned it using two for loops, one nested inside the other. And I'm going to go ahead and print out the results the same way, but I'm going to use the for each loop that we've talked about before. So I'm going to say I'm going to have an int array called row in matrix. And that creates an array called row, which has elements in it. So now I can go through those row elements. So I can say for int call in row. And I can system.out.print call. And so what I've done here is this is going to give one row out of the matrix, and then I'm going to go through that row column by column and print out the elements. And then of course it would be really nice to do a system.out.print line to print out lines in between, and we'll go ahead and make sure this loop is in braces because I kind of need it. And so now if I run this, if I haven't done any egregious errors, like this one, so I don't want int array, this is just an int. So the thing is, my row is composed of integers. Each column is an integer value. That was my mistake here. So I see the 2, 3, 4, 5, 6. Let me put a space in here just to make it more legible. So I do the 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, and 7, 8, 9, 10, 11. Exactly the same as what I predicted up here. So the idea is that I could have used that same for each loop up here to assign. I could have used the same nested for loop up here to print it out. But the idea is that whenever I want to traverse a matrix, whenever I want to put data in or get data out of an existing matrix, I need to do it this way. I need to do it using a series of loops, either for loops or for each loops or while loops. But I need two loops, one addressing the row and one addressing the column. So the only other real thing that I want to talk about here is the idea of the thing is, we have string literals and we have array literals, and if a matrix is just an array of array, then certainly I could have a matrix literal. And so I'm going to go ahead and do the same idea here. So I'm going to say char, and I'm going to make it a matrix, and we'll call it words, gets, and I'm going to do this as a literal. So inside here I'm going to have an array of arrays. So I'm going to have, let's go ahead and call this, let's say A, L, P, H, A, B, E, and T. So that's my first row. My second row, we'll go ahead and say, and I love this auto formatting here, N, U, M, B, E, R, S, comma, and because I'm separating these elements of this outer array. And then here's my next one, which is going to be, let's do 1, 2, 3, A, B, C. So this is an example of an array literal where this is a jagged matrix. In other words, the elements are not going to be the same. But I can do the exact same nested loop that we talked about to print this out. The only thing that I really need to change is that it's not an int array, it's a char array, and our elements are characters, and the name of my matrix is words. So if I run this again, it should print out, gadzooks, I forgot a semicolon and all that happened. What did I do wrong? Oh, I forgot to close one char, and the world exploded, and I forgot to open that char. That's why you need to proofread stuff. It's kind kind of essential. So I see alphabet, I see numbers, and I see 1, 2, 3, A, B, C. Notice that this matrix right here that I made actually had jagged lengths. Each one of the rows had a different length, and this loop was able to traverse it with no problem. So the main idea with what we're going to be doing this week in class, dealing with matrices, is we're going to be dealing with arrays of arrays. And you're going to have to traverse them either by putting data in or taking data out using nested loops, one loop for each parameter. And keep in mind the examples that I've done here, these are two-dimensional arrays, but I could have easily done three-dimensional arrays where I talk about X, Y, and Z. So instead of just being in column 2 and row 3, I could be column 2 of row 3 of sheet 3. And those of y'all who've dealt with Excel documents have noticed that you can have a row, a column, and a sheet. I certainly could extend this to 4 dimensions, talk about the X, Y, and Z position and the time for a helicopter that's flying. So I could talk about 4-dimensional analysis. Basically think of it as an array of arrays. And I can continue this as deep as I need to. However, for the AP, we're only going to be dealing with 2-dimensional matrices. And the AP is going to be dealing almost exclusively with rectangular matrices, not jagged matrices. So we'll continue talking about matrices this week. But once again, this is Mr. Potter. Thank you for watching. Have a great day.